Guys, welcome back to Shabez online tutorial. In today's tutorial, we're going to look at what implicit differentiation. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at Shabez online tutorial. So the function on the board number one, we are given x to the power of 4 plus y to the power of 4 is equal to 10. And we are asked to look for the value of dy over dx. Also to the second question, which is Roman numeral 2, x to power 2 plus 2xy plus y to power 2 is equal to 12. So let's get started. Solution. So the first one we have x to power 4 plus y to power 4, which is equal to 10. And to get the dy ds of this function, what we are going to do is to differentiate with respect to x, and anywhere we see y, we differentiate with respect to y, but we add dy over ds. So this is implicit differentiation. So if you differentiate x to the power of 4 with respect to x, we are going to have what? 4x to the power of 3 using power rule. Then plus also we differentiate y to power 4 with respect to y is going to give us what? 4y to power 3. But since we are differentiating with respect to x, we are going to add what? dy over ds whenever you differentiate with respect to y, which is equal to, if you differentiate 10, 10 is constant and the derivative of constant is the same as 0. Now the next thing we're going to do is to make dy over ds the subject of the formula, because from the question we are looking for the value of dy over ds. Now I'm going to take this 4x cubed to the other side of the equation. We're going to have 4y to power 3 dy over dx will be equal to, if you take this to the other side, it's going to be what? Negative 4x to power 3. Now the next thing we're going to do is to divide both sides by the coefficient of dy over dx, which is what? 4y to power 3. Then also we divide by 4y to power 3. So 4y to power 3 will cancel out 4y to power 3. So in the left hand side, we are left with what? dy over dx, which is equal to, if you this 4 is going to cancel 4, we are left with what? Minus x cubed over y cubed. So this is the value of dy over dx in this function using implicit differentiation. Now let us look at the second function, which is what? X to power 2 plus 2xy plus y to power 2, which is equal to 12. Now we're going to differentiate this with respect to x. We're going to have what? 2x to the power of 1 is the same as 2x using power rule. Then plus, so this is product rule. We're going to differentiate 2x, then we keep y constant, then we differentiate y and keep 2x constant using product rule. First of all, we differentiate 2x with respect to x, we're going to have 2, then multiply by what? We keep y plus, multiply by, we keep y constant, then plus, we're going to keep 2x constant, then we differentiate y. So if you differentiate y, remember, anywhere we differentiate y, we're going to add dy over ds. Derivative of y is the same as 1. 1 multiplied by 2x is, it will still give you 2x. Then we add what? dy over dx. Then plus derivative of y to the power of 2. Remember, there's no x here. We are going to differentiate with respect to y, but remember to multiply by dy over dx. So derivative of y squared is the same as what? 2y. Then we multiply by dy over ds, which is equal to derivative of constants is the same as what? The same as 0. Now I'm going to have what? 2x plus what? 2 multiplied by y is going to give us 2y. Then plus 2x dy over dx, then plus 2y dy over dx, which is equal to 0. Remember, we're looking for the value of dy over ds. Now we're going to move all the time with dy over ds in the left hand side and all the time without dy over ds to the right hand side. So in the left hand side, we're going to have what? 2x dy over dx, then plus 2y dy over dx, which is equal to, we're going to take this 2 to the other side of this equation. It's going to be what? Minus 2x. Then this plus 2 is going to also cross, is going to be what? Minus 2y. Now the next thing we're going to do, remember, is look at this coefficient. We have 2, 2, 2, 2. Now we're going to divide all through by 2 in order to eliminate the 2. 2, then 2, 2. So that this 2 is going to cancel this 2. 2 is going to cancel this 2. This 2 is going to cancel this 2, and this 2 is going to cancel this 2. We are left with what? X dy over dx plus what? Y dy over dx, which is equal to minus x minus y. Now, the next thing we're going to do, we have dy over ds here, also dy over ds here. We're going to factor out dy over dx, and we open bracket. We're left with only x, then plus, this place remain only y, which is equal to, we can factor out minus 1 here. If you factor out minus 1, we are left with what? X plus y. So that if you expand this bracket, we're still going to get back minus y, minus x plus, minus x and minus y. Now, the next thing we're going to do is to divide through by the coefficient of dy over ds, which is x plus y. We're going to have divide by what? X plus y, also what? X plus y. So that this x plus y will cancel this x plus y also cancel this x plus y. So we are left with only dy over ds in the left hand side, which is equal to -1. Therefore, the value of dy over ds in this function using implicit differentiation is equal to -1. Thanks for watching, and please don't forget to subscribe to my YouTube channel. Also follow me on Facebook, TikTok, Instagram at Shabes Online Tutorial. Thanks.